Chapter 4, Section 4. Objective is to learn to evaluate expressions with exponents. An essential question, how do I write and use scientific notation? Some vocabulary for us is scientific notation. An ordinary quarter contains about, check that number out. Any idea what that might be? Hundreds, thousands, 100,000s, 200,000s. Maybe you want to Google that and see how you read that number. The average size of an atom is about 0.00000003 centimeters across. See if you can figure out the value of that number. Those are really big and really small numbers that we're working with. The length of these numbers in standard notation makes them awkward to work with, and standard notation is exactly the way they're written right now. So if we needed to work with atoms, and we wanted to look at an ordinary quarter and the amount of atoms in it, we may want to use a different type of notation. That's where scientific notation comes in. It's a shorthand way of writing these types of numbers, really big or really small. The scientific part should help you remember that a little bit easier, because in science you often work with very, very small particles, atoms, different items, or things that contain a lot of them. Numbers written in scientific notation are written as two factors. One factor is a number greater than or equal to 1 and less than 10. The other factor is a power of 10. That part that's highlighted in green is very important. The first number needs to be greater than or equal to 1 and less than 10. So let's work backwards first. This is scientific notation. Let's write the number in standard notation. So if we have 1.35 times 10 to the 5th, that means we're going to multiply that number by 10 to the 5th power. And 10 to the 5th power means we're going to move that decimal 5 times. Because it's a positive, we're going to move the decimal 5 places to the right. So we get the number 135,000. If we were to have a negative exponent with the 10, we would move the decimal to the left. So 2.7 times 10 to the negative third. Here we have a negative exponent. That means move the decimal left 3 spots. So start with your pencil at the decimal, move 3 spots to the left. We get 0.0027. You can see the steps leading up to that are showing what's really going on, but we don't need to show our work when it comes to that. As long as you understand that it's shifting the decimal, that's what we need to know. 2.01 times 10 to the 4th. Positive 4 means we're going to move it to the right 4 spots. So move that decimal 4 places to the right. You get 20,100. 1.9 times 10 to the negative 5th. Move the decimal 5 places to the left. Starting at the decimal, we would have 0.000019. Let's work the other way. Let's write these numbers in scientific notation. For numbers greater than or equal to 10, use a positive exponent. For numbers less than 1, use a negative exponent. So just like when we were moving into standard notation, when we had a positive exponent, we ended up with a whole number. When we had a negative exponent, we ended up with a decimal. To write scientific notation for numbers greater than or equal to 1 and less than 10, use a 0 exponent. So 5.63 equals 5.63 times 10 to the 0 power. We don't normally see that because that's not changing the value of the number at all, but that's what that would mean. So let's write this decimal in scientific notation. First we have to figure out where to move the decimal point to so that we have a number that's between 1 and less than 10. Well, we have to move it either in front of the 7, behind the 7, behind the 0, behind the 9. I think it makes sense to move it behind the 7. So when we count how many steps we took to get there, it was 1, 2, 3. Because this started out as a decimal, I want to have a negative exponent. So I would write out every digit after the 7 until I run out of numbers or that the rest of it is zeros. So 7.09 times 10 to the negative third power. That's scientific notation for that number. For this decimal, I know it's going to be a negative exponent because it's a decimal. I need to find a number somewhere greater than or equal to 1 and less than 10. So I see the number 8. So if I move the decimal after the 8, I have the number 8.11 times 10 to the power. It's a negative, and I moved it 1, 2, 3, 4 steps. So 8.11 times 10 to the negative fourth. A certain cell has a diameter of approximately 4.11 times 10 to the negative fifth meters. A second cell has a diameter of 1.5 times 10 to the negative 5 meters. Which cell has a greater diameter? Here's our two values. Both will be smaller decimals because of the negative exponent. But because they're both 10 to the negative fifth, we're going to end up moving the decimal the same amount of places. So we can really just compare the numbers that we already have. And 4.11 is greater than 1.5. Let's look at one more example with a positive whole number. Write the number in scientific notation, 13,432. So if we look at our four options, we can see we can narrow this down a little bit. The first number in a scientific notation value has to be greater than or equal to 1 and less than 10. So that narrows it down to either A or C. Second part is that because this is a whole number, we know that it's going to be a positive exponent. So that narrows it down to A. And that wraps up Chapter 4, Section 4. Make sure your notes are filled out completely. On the left-hand side, write the questions that could be answered from the material in your notes, and review your notes and complete the summary before class.